This is definitely the most detailed explanation video of the scooter engine ignition system you have ever seen, presented in super intuitive 3D animation form, so that you can truly understand the working principle. Pay attention, this is the spark plug cap, high voltage wire and ignition coil. The spark plug cap is composed of a spark plug connector, a spring, and a threaded metal rod. The ignition coil consists of a primary coil, a 4-pole coil, and a magnetic core. The ignition coil acts like a transformer, converting the vehicle's low-voltage current into high-voltage electricity to ignite the spark plug, and is a key component of the engine. This is the igniter, which receives and stores the ignition voltage provided by the magneto and accurately calculates the ignition timing. It is the starting device of the motorcycle. It has 5 wires. One is connected to the ignition coil, the second is connected to the switch. The third is connected to the engine housing along with the switch and ignition coil, that is, to ground. The advantage of this is that it can avoid poor contact or line heating. This is the generator coil and inductive sensor. This is the winding that powers the sensor. The output wire is connected to the 4th wire of the igniter. The 5th wire, the blue one, is connected to the sensor. The sensor consists of a magnet, a steel core, and a coil. The other end of the sensor is connected to the housing through a bracket. At this point, you can see that the entire circuit forms a closed loop through grounding. The rotor of the generator has 8 magnets with alternating polarities. The stator is a fixed coil. The magnets on the rotor rotate around the stator to generate an induced current. Each output of the stator serves a different purpose. As shown in the figure, the coil used for ignition has a denser winding of fine wires than other coils to generate higher ignition voltage. There is a metal sheet on the outer ring of the rotor. I will talk about its function later. For a more intuitive understanding, let's disassemble the igniter. Look carefully. When the rotor rotates, the generator set generates an AC voltage, and current is output through this black wire and first flows to the igniter. Note that here, diodes only allow forward current to pass. The current continues to flow through the capacitor of the igniter, then flows to the primary coil of the ignition coil, and then forms a closed circuit through this green wire connected to ground. If you don't see it clearly, you can pause and observe carefully. In this process, the capacitor of the igniter will be charged. When the metal sheet on the generator rotor passes through the inductive sensor, a pulse will be generated in the sensor. The pulse flows through this blue wire's resistor and capacitor and reaches gold gate pin of igniter. Then gold gate opens, forming a new closed loop. The charged capacitor will discharge into primary coil of ignition coil. Current flows through primary coil, generating electromagnetic induction, which further enhances magnetic field, and secondary coil will induce ultra-high voltage. When voltage reaches required value, secondary coil discharges through spark plug, electrode gap igniting mixture in cylinder. When capacitor fully discharges, transistor turns off. Whole process repeats, so ignition coil energized again, driving spark plug work, forming correct ignition timing. When ignition turned off, switch closed output, current shorted shell charging voltage capacitor, discharge shell through diode capacitor, no longer charged spark, no longer generated. This is working process entire ignition system. Isn't it very clever? Like and follow for more informative 3D videos.